Hello programmers, and welcome to the C++ for Beginners series, Video 11, Vectors. In this video, we will be looking at C++ vectors and how they can be used to work with large amounts of similar data. First, let's do a quick review of what we learned about vectors so far. In Lesson 10, we learned vectors are a sequence class that is part of the C++ standard template library. You need to include vector at the top of the program. You declare a vector with the keyword vector, the data type of its elements, and give it a name. Like arrays, vectors can represent a collection of data of the same data type. Some examples might be student grades, billable hours worked each week for the last 12 months, or using an example from an earlier video, the daily temperature highs for the past year. While a 365 element vector is easy to declare and use in C++, for this slide I think I'll limit the example to the past 7 days of daily temperature highs, or the highs for the past week. And on the slide you can see I have a vector of data type double named daily high, and within it I've just input 7 random values for represent temperatures. Also, since vector is part of the standard namespace, we need to be sure to prefix it with std::, just like we do with cout. We can access the contents of a vector by referencing the index of the element we want to retrieve. Now I have a couple output statements representing how we can access this data. The first one, we're accessing daily high index 3, so it will print out 85.7. The second one, we're using a different function, the Vector.add function, to reference index position 2, which is going to print out 82.3. Also, just one more time, in the code we need to include vector at the top of the program in order to utilize vectors. Keyword, given the data type a double, name again daily high, and for now I'm just going to give it 4 elements. Up top I've just recreated the reference of the vector from the previous slide. And also at the top, be sure that you include vector into your program. Okay, I went ahead and copied in 3 more lines of code. The first one, we're going to insert some more data into our vector. So when we initialize it, we've created 4 elements. So this line here, we're going to utilize the Vector.insert function to insert some more data into the vector. We're also utilizing the Vector.begin function to position our start point for the insert operation. And we want to insert from the beginning of the vector, which is right here, index 0. And we want to move up 4 positions. So 1, 2, 3, 4. So we're going to insert the value 78.4 at index position 4. The second parameter I should have mentioned is just we want 1 element of data. So starting at index position 4, we're going to insert 1 element's worth of data with a value of 78.4. And that will fill out our vector up to here. The last 2 lines are going to populate index positions 5 and 6. So how the vector pushback function works, it's going to insert the value of 81.9 into the last current element of the vector. So these 2 lines of code up here filled out our vector up to here, element 5 or index position 4. The first pushback is going to populate element 6, index position 5, with a value of 81.9. Then the last pushback, of course, will fill out our last element, 7, or at index position 6, with a value of 88.5. Okay, now we can display these and print these out. Instead of writing out a bunch of cout statements to display the vector values all the time, cluttering up our code, let's utilize a function instead. So for now I'm just going to put it at the top of our main. Okay, so it's going to return void since it's just going to be a print function. And let's just give it a name, something like print_vec for print vector. And we'll also need to give it a parameter, the vector that we wish to print. So to do that, we have to declare the data type. But in this case, instead of using int or double, we're actually going to give it a data type of a vector. So to do that, you just kind of, like the same syntax when we declare a vector, standard vector, and vec. I'm just going to call the temporary name vec for the placeholder. So one thing I should point out, when a vector is passed into a function, a copy of the vector is created. So in this case, we're creating a copy of our daily high. We're just going to call it vec within the print vector function. If we made any changes to the vector within the function, they would not affect the original vector that we passed in. So just hypothetically, if this function would perform some operations on the vector changing these values, when this function ended, the daily high vector would remain intact, unchanged. This may or may not be what we want to happen depending on the function. In our case, since we only want to print the context of the vector, it should work well. However, in the cases of large vectors, this could cause a performance hit. So we can avoid this by passing in by reference. And you do that by using the ampersand symbol. So we put an ampersand in front of the vec. Oops, get her down here. Ampersand in front of the vec name. Now, instead of passing by a copy of it, or passing by value, we're actually passing by reference. So now, any changes that we make within the function actually would apply to daily high. In some cases, if this was a vector or a function that was modifying the vector, this would be exactly what we want. But in our case, again, since we only want to print it out, we do not want to do that. So we can avoid modifying the data of the vector by using the constant keyword. So just prefix it with the keyword const like this. That ensures that any changes that we make within the function will not be applied to the daily high in the main. So actually in our function parameter list, let's use the auto keyword for our vector. That way, instead of just having to print out, having it work with double vectors, we can use ints or any other data types. We'll let the compiler figure out which data type it should be. So now we can start to code the body of the function to print out the vector contents. Actually, before we do that, let's just add one more parameter to our function first, as we may also want to display the name of the function. Because I want to use this for example, so I just want to differentiate the different functions that we're printing out. So to do that, let me just create a new variable with a string, type string. I'm just going to call it n. And actually, I think I'll also give it a default string, right? An empty string. Just to initialize it. That way, if the user calls the function without passing a string variable, it will still run. So basically, the minimum requirements pass a vector name. Then the optional requirements to pass also the name that we want to print out. So the first thing we probably want to do is check to see if a user passed in a string or not in the function. To do that, we're just going to check the value of n. And by default, since it's just an empty string, so if n is not equal to an empty string, then we'll perform the code in the if statement. In this case, we're going to add a little bit to our output, so we'll just make a cout, print the value of n, again, which would be the user supplied input string, and probably a little text like is. And that should work. We're going to have a follow-up output, so I won't put a new line or anything here. So basically, this if statement is going to be if n is not empty, go ahead and run this code. If the user does not provide a string or n is empty string, it's just going to skip it and move on to the next line. And so for the next line, we're going to actually want to print out our variable. And to do that, I'm going to use a range-based for statement. So in this case, since we're inside a function, it can be pretty simple. Again, we use the auto keyword since we don't know what type of vector is going to come in. And for the iterator, I'm just going to use v. Makes it pretty simple. And of course, the vector, we need to use the name we gave it up here, or vec. Then inside the loop, again, we can do an output statement. And we're going to print the value at the current element. Then we'll just pad some space in between them so it's a little bit more readable. And notice here in both these, since I'm only using one line of code, we don't have to encase them in curly braces, both in the if statement and the for loop. And down here, I'll just give it one more cout. Give it a new line. Give it 2 new lines. Just to make it a little bit more presentable when it prints out. Okay, so that should work fine for printing out our vectors. Okay, let's go back down in main and test it out. So we can just simply call it print vec. We'll pass in our daily high. And hopefully we compile and run it, everything works. Should be a parenthesis there. Okay, let's give it another try. Okay, and there we go. Print out the contents of our vector. And notice we have the first 4 elements that we initialize on the declaration. The 78.4 that we inserted using the insert statement. Then the last two, 81.9 and 88.5, using the pushback statements. Okay, so that should save us a lot of typing and code clutter as we go over our examples. However, let's test it one more time. Notice I just passed in the vector, so the default. Close this. But it's also, let's pass in the second parameter, the optional second parameter name. Of course, that's a string, so we have to put in quotes. And we just call it the daily high again. Just so we can differentiate our vectors when we print multiples out. Close the original. Compile and rerun it. And here you can see we're just prefixing daily high. So this way, once I print out multiple vectors, it's a little bit easier to see which one is referring to which. Okay, so I just went ahead and cleared the screen of the last example, but I did leave our handy print vector function intact. I've also created 3 new vectors, named simply Vector1, Vector2, and Vector3, V1, V2, V3. Set some initial values for Vector1, however I'm leaving Vector2 and Vector3 empty for now. And for Vector2, we can utilize the pushback function. And this, for now, I'll give it a value of 11. Copy and paste that. And for Vector3, we can use the assign function once again. And this form is going to take, the first parameter is going to be how many elements we want to populate. So I want a vector assign it 10 elements, and I'm just going to assign each element a value of 42, just for this demonstration. Okay, and off screen I just did our output statements. So just kind of a little title for the section. Then again, utilizing our print vector function, and give it the value of Vector1, and just little titles for each one as it prints out. Okay, so let's go ahead and compile and run it. Now we can see our initial assignments. Again, Vector1 that we got from the initialization list. Vector2 that we got by using the pushback function. And Vector3 here assigned 1042s using the assign function. Okay, and here I've just added 3 more lines of code. And we're going to reassign Vector3 values. So up here we assigned it 10 values of 42. We use the assign. I just want to emphasize that the assign function is actually going to erase the contents of the current vector. So in this case, it's going to erase our 1042s and instead replace it with 5, 6, 7, 8, 9. So we go ahead and compile and run it. You can see that's exactly what happened. So you got 1, 2, 3, 4, 5. Vectors 1 and 2 remain to change. Here's the vector 3 originally, and here's after we ran the reassign. Okay, now I've just entered some more code, and this time we're just going to demonstrate the assign function where we can actually assign it vector 3 the value of vector 2. We can do this by starting Vector.begin, which is very start of vector, through the end of vector 2. So we compile and run this code. We can see now that v3 contains the contents of vector 2. Okay, now just going ahead and we're going to demonstrate inserting vector 3. Let's insert into the vector. So instead of assign, insert, we can actually insert data without disturbing the contents already in the vector. So here, I'm going to use also the Vector.begin function. So we're going to want to begin at 0 and 1, 2 index positions. I'm going to insert 3 elements of value 99. So let's go ahead and compile and run that. And here you can see that we indeed inserted 3 values of 99. But we left the original data intact. Here was a value of v3 just before under prior code example. Here it is after we use an insert statement to insert our 3 values of 99. So we still have the 11 to 22, 33, 44, and 55. So the insert statement just basically insert these, and each time it ran, it's just pushing back the existing values. So insert's useful for when you want to insert data but not lose existing data. Okay, the next section of code I just added, we're demonstrating the Vector.erase function. Just like insert, erase takes 2 positions. So here we're using the begin function to specify that I want to start with element 2 up through element 5. So I'm going to erase the contents from 2 up through, but not including 5. So if I go ahead and compile and run it, here you can see, so we started 0, 1, 2, so I erase this 99, 99, 99. Up to 5, but not including element 5. So basically now after the erase, we're just back to our original version, vector 3. In the next section of code, utilizing the pushback function again. Again, pushback is simply going to insert a value of 99 at the very end of the array. So let's compile and run this. Here's our pushback. So we just have our array, and now with the addition of value 99 at the end. Like pushback, there's also pop back, but instead of adding data, it's going to remove data at the back. By default, it's just going to remove the last element of the vector. So we compile and run this. We can see that's removed the 99 we inserted previously. Now our vector 3 is back to our initial state. Okay, and these next 4 functions I want to go over don't really do any manipulation with the elements, but they just return values. So we go ahead and compile and run this. So here, back is just returning the last element in the vector, which we can see up here is 55. Front is going to return the first element in the vector, of course, since it's 11. We've seen size already. Size is just going to return the size and the number of elements, which we have 5 elements. And the new one, capacity. Capacity is returning 10. So at first you might be confused and think capacity is the same as the size, but capacity is just the size of the memory that we have allocated to the vector. If we go back up here, when we originally assigned vector 3 values, we actually gave it 10 elements. So just because we've resized it since with 5 elements, the computer still has allocated 10 room and memory for 10 elements. So just keep in mind these actually are different. Size you can think of as the current value or the current number of elements of the vector. or capacity is the currently allocated size. Again, this ain't the maximum because vectors can be resized, but it's just what's currently allocated in memory. So moving on, we can also demonstrate the vector swap function, where we can swap the contents of one vector with another. Here I'm swapping vector 1 with vector 2. And I've also got a print statement so we can show the state of the vectors before the swap and after the swap. So we go ahead and compile and run the code. Here we can see the values of them before the swap, just as they were above. And here's the values after the swap. Notice that they just simply changed elements. And one more function, the vector clear function, which, as you might expect from name, is simply just going to clear the contents of the vector. Here I'm going to clear the contents of vector 1. So we go ahead and compile and run it. Let's close this one. We can see vector 1 is empty. Notice though that clear does not delete the vector, it just simply clears the contents. So vector 1 is still defined, it's just right now has no elements. Okay, so that's about only half of the vector functions available to us, but it should cover pretty much most of the ones I think we'll use, at least at first. I'll put a much more complete list on the companion website, where there are also plenty of references available online. But to end the video, I first want to go over a multidimensional vector. Okay, with 2D vectors, you can think of them just like you would an array in terms of columns and rows. This first example is declaring a vector, 2D vector. So we use the keyword vector. Notice I'm not using the standard prefix here just for clarity. So here we're using the keyword vector, and we're going to use the data type, this time a vector int. So notice this ain't declaring a vector, it's actually specifying the data type as a vector for our vector v1. And we're declaring it 3 groups of elements, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can think of the inner brackets as kind of like the rows. So row 1 is going to have columns 1, 2, 3, row 2, 4, 5, 6, and row 3, 7, 8, 9. And that example would print out the output you see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the second example, we're actually going to have a user defined size. So instead of being set statically on declaration, this one can be sized inside the program. So this one you can think is more like a vector within a vector, as you could have one vector container holding 10 different sized vectors within it. But for now, just think of this example like a table of 10 rows with 10 columns. I've brought up another slide to help visualize the concept, as the last example might have left you a bit confused. In this example, I'm creating a simple 3x4 vector. We declare it by using the keyword vector. It has a data type of vector int. I'm naming it v4 for vector 4. It also has a parameter list, with the first being the number of elements in the vector. You can think of this as the number of rows in the vector. The second parameter represents the values we're putting into the vector's elements, which in this case are vectors of data type int with y number of elements. So each of the 3 elements in vector 4 will contain an inner vector with 4 elements each. You can think of vector 4 as containing 3 vectors of 4 elements, so we end up with 12 accessible elements in total. Looking at the square representation of the vector, the whole container is considered vector 4. Along the left, we have the elements of vector 4, which we can think of as the rows. The number of rows is determined by the variable x, and of course, in this example, we have 3 elements with indexes of 0, 1, and 2. Within each of vector 4's 3 elements, we have another vector, which themselves contain 4 elements each. I have y inside each of these elements, just to represent where they are being declared from in the vector statement above. Each inner vector has y number of elements, in this case 4 each. So once again, vector v4 is a vector of 3 elements that each contain a 4-element vector. Or when we think of it in table form, as shown here, we have 12 elements in total arranged in a 3-row by 4-column table. While visualizing it in a table form is helpful for us humans, it can probably be more accurately thought of as a sequence of elements, as shown in the lower example. Since memory space is allocated sequentially, the vectors formed inside the computer will more closely resemble this shape, as the elements will usually be part of a contiguous memory space. As before, the whole thing is vector 4, which has 3 elements, represented by index 0, 1, and 2, with the number of elements being determined by the variable x above. Within each of those 3 elements, there is another inner vector, each of which has 4 elements of their own, with the number of elements being determined by the variable y above. So we end up with 12 accessible elements in vector 4 that we can access by specifying the v4 element or row, an inner vector element or column. Let's move back to the code and I'll show you an example. Okay, so to start with, let's put our example into its own separate function just to make it a little bit easier to see. It's not going to return anything, it's going to be a void. It's just going to print something out. Let's call it times table. It's going to be a multiplication table. And it's going to take no parameters. Let's build out the body. So to start out with, let's just give it like a little title. First, I'm also going to give it 2 variables so we can easily change the size of the table. X and initialize, I'm just going to set them to 10 each. And we got the somewhat messy part again. We're going to make our 2D vector. So I'm declaring the standard vector, which is just a keyword saying we want to make a vector. Then I'm going to give it the data type. Now this is the data type. This is probably where it gets confusing. But instead of making a vector here, I'm actually declaring the data type of our vector. A vector. And the inner one's got the data type of integer. And we're naming it vector 4, v4. We're going to give it some parameters, and the parameters are going to be x for the number of rows, and also the elements, just like the slide before, are actually going to be vectors themselves, and each of those subvectors, I guess you could call them, are going to have y elements, which will represent the columns. And since I assigned each x and y with a value of 10, we're basically going to have a vector, or creating a vector of 10 vectors of 10 elements each. And they're all within a single vector named vector 4, or v4. So again, it looks confusing, but it is the same syntax we have been using. The outer standard vector is like always, just a keyword. We want to declare a vector. The first inner standard vector is actually the data type for the parent vector. So instead of just simply int, we're actually creating a data type of vector int. Then again, we're naming it and just giving it some parameters, x by vectors y. Okay, so like we did with the 2D array in the previous lesson, we can use nested for loops to fill the vector of data. So let's just go ahead and create a for loop. And we'll start off with 0 because the vector elements actually start with 0, the index positions. And of course we iterate up through our value of x. So we'll be going through 0 through 9, which again equates to 10 elements, so we should be good there. And again, just standard incrementer. Then we'll have our inner for loop. And here I'll just use j. Again, starting at 0. J is less than y for our columns. And again, just increment j. Then we're going to assign some values. So vector 4. And we're going to want to assign element I, which in the first run through is going to be 0. J, so 0, 0, the very first element in the vector. We'll assign that the value. We'll have to do a little math here. So the value of I plus 1, since we have to offset for the 0 that we initialize with. We need the 0 because the index is start at 0, but to do the math, we just want to start with a 1. So then we'll multiply that by j plus 1. Okay, and that should fill our vector with kind of the elements of a multiplication table. And to print it out, since we can't really use our function up above because that's only designed to handle one-dimensional vectors, this is a multi-dimensional, we'll go ahead and create a range space for statement to print it out as we have been using. And we'll dereference the value here of our iterator before. And of course we'll be needing the inner loop. So for, so make that a constant, so no danger of changing. Dereference. And just give it, we'll print out. And just give it a tab in between to make it look a little bit nicer. And after each row prints out, we'll just give it a new line. And give it 2 and make it look nice. And since we got multiple statements in the first one, I'll have to actually close that one in brackets. Okay. I think we should be good. Let's compile and run and see what happens. Okay, no errors, but it didn't print out because, of course, we got to call it up here in our main. So we'll go ahead and just call times table. And let's try it again. And of course, it don't compile because I put it at the bottom of the function, so I'll actually have to put a declaration at the top. Remember from other lessons. I put our print function on top, that's why it worked fine, but here I'll just put a declaration up here. Let's try it one more time. Okay, and there we go. We got all our examples above, but at the bottom here is our times table that we just printed. You can see just 1 through 10, and 1 through 10 in the columns, and of course 10 times 10 is 100. 2 times 2 is 4, that's why I kind of call it multiplication table or times table, whatever you want to call it. It's kind of a neat little demonstration. And what we can also do is just change, back down here to it, change the values. So if we want to make, say, a 12 by 12, and of course now it goes 12 by 12, and of course 12 by 12 is 144. And we can do just one more quick run. Let's maybe make it 5 by 5 just to see a little bit smaller. Compile and run it. Okay, it looks pretty good, but I'm noticing the title could use some work. Not a big deal, but hate to leave the final example incomplete. So let's make 2 modifications actually. One for centering the title, and the second, let's pass the variables into the function in case we want to call different size tables from our program. So instead of hard coding the variables within the function, we can pass in the parameters. So instead of declaring them within, we'll just do them x, of course, y. And before I forget, let's also modify it up here. So int x, and I don't give them default values too. You do that up in the declaration. Let's give them default 10 each. That way if, say the user does not just calls it like we did earlier, it's just going to default to 10 by 10 times table. So we got our declarations, go back down. So we're input those. We don't have to supply the values here since we did up in the declaration. And since we're passing in the variables, I'm just going to go ahead and comment these out for now. If everything works out, we can delete them later, but just so we got the reference. Let's also work on the title here because we want that centered depending on how we scale it. So one way we can do that, remember back in lesson 2, our improved hello world, we can do some string manipulation. So let's actually create a string then to hold our title. And we'll just call it, title works. And we'll assign that. We can basically just copy in our existing title here. But the only thing you notice, the new lines and stuff works fine. I'll just comment that out too for now. New lines work fine. It was the tabs that we had issues with. Like when it shrunk down, it was kind of small. And we'll also have to do a standard cout now to actually print our title. Leave the old title commented out for now just as a reference like the variables. We'll delete all this later if this works out okay. So I'm just going to go ahead and run it, pass in a 3 by 3 just to see what it looks like. And okay, it looks pretty good. Notice the title's still off a bit, so let's just get rid of that last tab. Give that space and run it. Maybe keep the space. Okay, it looks pretty good that way. So we know with a 3 by 3 it will look pretty good. Let's try a 4 by 4. Okay, 4 by 4 is where it kind of starts to break, so we could probably use a tab there. So we just put a tab in quick. And not perfect, but it looks a little bit better. Maybe I can get rid of that space. But we also want this to scale then. So if we go something bigger, 12 by 12 or 15 by 15, we want to scale. So, and we want it to be centered. So basically for every tab, notice down here we're actually tabbing every time we print out a character. So for every 2 tabs, keep it centered, for every 2 tabs we're going to want to add 1 tab into our title. The baseline is going to be with 0 tabs. So that's up to 3. So, but once we get to 4 elements, we're going to want to add 1 tab and so on. So one way we can do that is we can take the value of y, the number of columns, and divide it by 2. But again, since we were fine up to 3, we won't want the very first value, so we want to subtract that. So let's do the value of y in columns divided by 2. And again, since y is an integer, if we do math, so say y is a value of 5, we divide that by 2, it's actually going to return 2. I mean, the actual value in floating point would be 2.5, but since it's an integer, it's just going to return a 2 and leave the remainder off. But if we subtract that then from 1, the result, so 2 from 1 is 1, that could be a good mark for how many tabs that we want to insert into our title. So what works good for that is going to be a for loop, since we're going to want to iterate depending on how big y is. Let's go ahead and make standard I equals 0. And here's where we got to use the math we just kind of talked about. So if I is less than, and it's going to be the value of y, like we said, the number of columns divided by 2. And we got to put that in parentheses because we want the division occurring first. And from that, we're going to subtract 1 because we don't want the very first time that happens. Basically, so we don't want the first tab to insert until we get to 4 or greater. So we do this. we should be good. Then, of course, we need to increment I again. Go through the loop. Then within the body, we're going to actually want to modify the contents of title. So if you remember back in the, as I was saying before, remember back to lesson 2 where we used the string manipulation so we can actually insert a character or tabs into the title. So we'll use title or string. We're going to use the insert. And does this look kind of familiar to our vectors, the insert? Well, it should, because strings are they're not the same, but they're very, very similar to vectors, and they're behind the scenes operation. So now another thing I need to point out, if you remember back again to the second video, any delimited character like tabs or new lines, even though visually they're taking up 2 spaces, internally to the computer this would just count as 1 character. So up here in our title we got index 0 and index 1 occupied by the 2 new lines. So we're going to want to do our insert of our tab at position 2. So let's give that the first parameter here. Then the second parameter is going to be what we're going to insert. Again, since it's a tab, we just use the tab delimiter notation like that. Okay, so now every time this loop goes through, it's going to take the value of y. So let's just feed it hypothetical 10. So we give it 10 columns. It's going to come through, and 10 divided by 2 minus 1. So it's going to be 5 minus 1, 4. So we're going to insert 4 tabs into the title here. So simple enough. And of course we got to move title underneath the loop so it actually outputs how we want it to. Okay, and I think that will work. Let's give it a quick check. And I got something wrong here. Oop, colon instead of semicolon. Let's give it another try. And there we go. I left it 4x4, but you know, it's not perfect, but it's better than being off here or way off to the right. So let's run this again. Let's just give it our default. Just make sure we didn't break anything like that. Close this one out. Compile and run. Okay, we get, there we go. Look at that, nice and centered. About the best we can do here. A 10 by 10 times table. Let's do maybe a 13 by 13 then and see what happens. There we go, a little tight, but it seems to fit without messing it up. So, and our title kind of self-centers, and again we go down something maybe like 5 by 5. Not perfect, but a lot better. So, okay, so there we go. And 2 nice modifications to the function here. We're actually taking input so we can actually change it within the main function and resize it. And we also played around the title a little bit just to kind of center it. And if we wanted, we could do things like, you know, we could put a clear screen and stuff on there, but I think that's enough for this video, and I didn't really want to drift too far off topic. But so I hope this video helped give you a better idea of the usefulness of using vectors. We went over the basics of creating and initializing a vector. We performed various functions of inserts, deletes, swaps, and copies of a vector. We also looked at passing a vector by value and reference when we created our little print vector function here. And we finished up, of course, just by making our multi-dimensional vector with our fun little scalable multiplication table. And actually this one might be a good one to include in your portfolio project, at least for now, so you got more than just one program to play with. I'll let that be your homework assignment. So why don't you go ahead and see if you can just just like we did back in the earlier lesson. Maybe put this in its own separate file and adjust your portfolio menu just to print that out. And also you could, add a clear screen and stuff so it wipes the screen clean and prints out your multiplication table. And maybe when you first get there, you can prompt the user to enter the height and width of the table or something like that. So go ahead and try that, and maybe the next or later lesson I'll go over it quickly. I don't want to spend too much more time in this video. But for now, that should wrap this up. And so until the next video, take care, and I'll see you then.